All right, so here we're going to look into multiplying and dividing radicals. Dividing isn't really, we're not really dividing anything in radicals. It's really more of a, we're actually technically multiplying. It's a weird way of simplifying them. But we'll get to those in a second. Let's focus our attention first on multiplying radicals. So when you're multiplying two radicals together, remember that rule we talked about in the simplifying radicals, where if you have two numbers, something times something in the same radical, that you can split them into their own individual radicals. Well, that's essentially what we're doing here, but in the reverse way. These are separate radicals, but why not, if they're both underneath the radical, put them underneath the same radical, right? 8 times 6. So that makes the square root of, what is 8 times 6? 48, right? So there you go. You've multiplied radicals. At this point, though, we have to simplify them. So big emphasis on simplifying radicals this entire section, this entire week, because we're going to have to do it yet again here. So we've multiplied, multiplying's done, but 48 is not a simplified radical. So remember, go back to your list of perfect squares and figure out which of these will divide into 48. And the biggest number is 16. 16 will go into 48. 48 is the same as 16 times 3. So when you separate these out, you get the square root of 16 and the square root of 3. The square root of 16 is 4. Square root of 3 can't simplify, so it remains the same. We have 4 square root of 3. So it's kind of a weird process because you're putting these together in the same radical, but then you're splitting them up later, but with the intention of simplifying. So multiplying is done by this point. Everything after here is just simplifying radicals. So we've been practicing that for a while. So get used to it. It's going to keep coming. All right. So here, 2 square root of 5 squared. Now, do not get in the habit of trying to distribute the squared. I don't really like that too much. It confuses you eventually when there's a plus and minus signs within the parentheses. It technically would work here, but I just, to avoid confusion later on, think of 2 square root of 5 squared as 2 square root of 5 times 2 square root of 5, right? Let's use this without the parentheses. I think it might be a little more clear. So 2 square root of 5 times 2 square root of 5. Let me just rearrange these because it's really, like I said, 2 times square root of 5 times 2 times square root of 5. So let's just reorder this. Let's put that 2 here. So we'll have 2 times 2 and then square root of 5 and square root of 5. That'll make a little more sense of what I'm about to do. So 2 times 2, as we know, we can multiply them together because it's already outside the radical. That's just 4. When you multiply these two together, though, you get the square root of 25, right? 5 times 5 is 25. And thankfully, 25, although it's not simplified, it's very easy to simplify because it's a perfect square, right? Square root of 25 is just 5. So we have 4 times 5. So the answer here is 20. So to keep it kind of simple, whatever you have that's outside radicals, so like 2, you can multiply them together. Whatever you have that's inside radicals, like the 5, you can multiply them together. You don't have to rearrange them like I did here. I only did that to kind of prove a point. But yeah, if it's not in a radical, you can multiply them together. If they're in radicals, you can multiply them together. You just can't multiply outside to inside. So you can't multiply the 2 and the 5 together like here because 2's on the outside, 5's on the inside. Only multiply what's on the outside with what's on the outside and what's on the inside with what's on the inside. So here, everything is on the inside of the radical, so everything is just going to get multiplied together. So let's start, 3y times 12y. I know the 3 times 12 is going to be 36, and the y times y will be y squared. So that's just multiplying these together. So when you simplify them, these are actually pretty simple to simplify. Separate the 36 and the y squared. Square root of 36 is simply 6. Square root of y squared is simply y. So we get simply 6y. All right. So yeah, multiplying these together is pretty normal, pretty standard stuff. Just remember to simplify as well when you get to it. Yeah, these people decided to do it a very, very odd way. But yeah, I liked my way a little better. So here we have kind of like anything else. You've seen this before, you just haven't seen it with radicals. Here you're just distributing square root of 2 times square root of 8 and square root of 2 times square root of 18. So if you want to write that out, you can square root of 2 times square root of 8 and then square root of 2 times square root of 18. But I'm going to go ahead and just multiply them, right? 2 and 8 are both inside radicals, so 2 and 8 can both be multiplied together. So that'd be the square root of 16. And 2 and 18 are both inside radicals, so I'm going to go ahead and multiply them together as well. So which 2 times 18 makes what, 36? So these are not like radicals, so I can't add these together. However, I can simplify each of them and see what happens. Square root of 16 becomes 4, and the square root of 36 becomes 6. And these are just 4 plus 6 at the end, so just simply answer is 10. So don't make this out to be harder than it is. I know sometimes people think, oh, you're adding radicals. I can just add 16 with 36 because they're both inside radicals. No, that's not the case. The rules are very strict. You can multiply them together when they're inside radicals, but you can't add them together unless they're like radicals. So 16 and 36, you can't just add 16 with 36. It won't work that way. To add, they have to be like radicals. To multiply, it really doesn't matter. You just kind of multiply whatever. So be very, very careful with that. I can definitely see mistakes being made in that regards. So just only add when they're like radicals. If they're not like radicals, you can't add. Simplify and then try to add later. All right. Give me 1 second. Okay. Sorry for that. The allergies are really getting to me, man. All right. One more thing. When it comes to multiplying, FOIL method. FOIL, FOIL, stands for first, outer, inner, last. So when you do F, you're doing the first term in the parentheses times the other first term parentheses. When you're doing O, you're doing the 2 most outermost terms, multiplying them together. When you do I, you're doing the 2 most inner terms together. And when you're doing L, you're doing the last terms together. So last term here, last term here. So it's just distributing, but it kind of like distributing a little bit more intensified. But I think we've seen this in the past before. Here you can see them working it out when they multiply things together. I'm going to go ahead. If you want to pause the screen to kind of look into it, you can. But I kind of want to just do one with you. So here we have 3 minus square root of 8 times 2 plus square root of 8. So we're going to FOIL. We're going to just distribute and multiply. So let's do 3 times 2. So 3 times 2 is going to make 6. Then we'll do the outer terms, 3 times square root of 8. Now, keep in mind, 3 is not inside a square root. 8 is inside a square root. So I can't multiply the 3 with the 8. It's kind of like multiplying 3 times x. You just get 3x. Here, we're simply going to have 3 square root of 8. So don't try to overthink that. Remember, you can only multiply them together if they're both on the inside of radicals. So there's my first and outer. Now we'll do my inner. So this is a -1 square root of 8, or just negative square root of 8, times 2. So that would make a -2 square root of 8. So be careful with that negative. Remember, think of that as -1. That might help. -1 times 2 is -2. And then you have the square root of 8 attached to it as well. And then my last terms, negative square root of 8 times a positive square root of 8 is going to be a negative. And if you want to multiply them together, you can, because they're both inside radicals. So it'd be square root of 64 to make it, because it's that is just simply the square root of 8 times square root of 8. So, which makes 64 is negative because this was a negative here. That's a positive there. So let's start simplifying. I'll keep that 6 alone for now. I know these two terms are like radicals. I can combine them. So 3 minus 2, it's just the same as if it was 3x minus 2x. It would be 1x. So here we will simply have just 1 square root of 8. I'm just going to go ahead and just write square root of 8. And the minus square root of 64 is now, we can simplify the square root of 64. Square root of 64 is perfect. So that is just, square root of 64 is just 8. So we have 6 plus square root of 8 minus 8. And then you've got first and last terms you can combine. 6 minus 8 is -2. So those two combined to make -2. And then you can just bring down the square root of 8. This thing's being kind of finicky. And that's your answer. You can't do anything more with it because the two terms you're left with, -2 and square root of 8, are not like radicals. Nothing you can do to change them. So you leave it as such. Well, okay. I guess I am a little bit wrong here. You do have to simplify the square root of 8 because it's not a fully simplified thing. So yeah, square root of 8 simplifies into square root of 4 times square root of 2, which simplifies into 2 square root of 2. So that's a more correct answer. Yeah, I apologize for missing that. All right, let's get into quote unquote dividing radicals. So we're not really dividing. It's just, if you remember back in a video we did earlier, when we did the simplifying radicals video, there were 3 rules. Rule number 1, which is the one we run into most often, is that the number inside the radical cannot be divisible by any other perfect square other than 1. So that's the rule, like when you see the square root of 20, how it's not simplified because it's divisible by 4, and 4 is a perfect square. So we simplify that square root of 4 and square root of 5. That's what that first rule is referring to. The second rule is you can't have fractions inside square roots. So that doesn't apply here. But the third rule was, and this is where it's going to matter, is that you can't have radicals in the denominator. So here we have the square root of 3 in the denominator. Now both of these, the square root of 11 and the square root of 3, are simplified radicals because there's no perfect square, 4, 9, 16, etc. None of these will divide into 11 or 3. So square root of 11 and square root of 3 are as simplified as they get. But the issue is the fact that there's a square root in the denominator. So here's how we're going to get rid of it. So you know how when we multiply numbers by 1, it doesn't change, right? 5 times 1 is still 5, right? Negative 13x times 1 is still going to be negative 13x. We're going to use that a little bit here, but we're going to tweak it. So here, we're going to multiply by 1, but we're going to multiply by a special version of 1. We're going to multiply by the square root of 3 over the square root of 3. Now, that's still technically 1, because remember, when you have anything divided by itself, it's the same as 1. 5 over 5 is 1. X over x is 1. So square root of 3 over square root of 3 is 1. So what I'm doing, I'm not really changing the value of my original problem. It's still the same value. And I chose the square root of 3 because what I'm going to try and do is make the bottom part a perfect square. And by definition, a perfect square is when you take something and you multiply it by itself. So I figure, well, let's just multiply square root of 3 by itself. Then that denominator will become a perfect square, and I can simplify it. So let's go ahead and multiply the top together. Square root of 11 times square root of 3 would be square root of 33. And the bottom, square root of 3 becomes the square root of 9. Now, the convenient thing here is now the bottom part is a perfect square, and I can simplify it. Now, So the square root of 9 will simply become 3, and that'll be it. Now I just got to focus on simplifying the top part, the square root of 33. Now, conveniently for us in this problem, 33 is not divisible by any of these perfect squares. It's technically as simplified as it's going to get. So this will be our final answer, square root of 33 over 3. This meets all three rules, and especially that third one, which is that there's no radical in the denominator. So remember the trick. When there's a radical in the denominator, just multiply the fraction by that denominator. Remember to do it on top and on bottom. So we have the square root of 5, so we're going to multiply both the top and bottom by the square root of 5. Because when you multiply the bottom by itself, it'll become a perfect square. So on top, oh boy, 13 times 5 is 65. So that's the square root of 65 and over the square root of 25. Now, 65 is, believe it or not, you can grab a calculator if you want to and see if 65 will be divided by any of these, but it's not. It's not divisible by any of those. So square root of 65 is as simplified as it's going to be, as weird as that seems. Square root of 5 is, or square root of 25 is 5. So your final answer would just be this. All right. So in the next video, we'll solve radical equations. All right. And that'll be the last one in the series. And we'll have a quiz coming up. Hopefully you guys do well on. All right. See you later.